Again, to me, the beauty of that is by using this machine, this multimeter, you can test these electrical components and you can know for sure if they are bad or not. In other words, you don't have to order one of these, and they can be really expensive, you know, this regulator rectifier, and come to find out that wasn't the problem. Okay? So again, understanding the meter and how to set the meter and use it can save you lots of money. That's a great thing. Okay? So next thing we're going to step into is how do these electrons move? So we're going to relate the electron theory and Ohm's law to the small engine. This is got a bunch of different names. I like to call it a rotor. Notice the big, it's steel. It attaches to the end of the crankshaft. You see the keyway in it. It's got a big bolt here that holds it on. But inside of it are some serious magnets. Okay? So what's happening here then is this is turning. Bolted to the crankcase is what is called a stator. The stator is made out of conductive metal. Notice the copper on the different poles here. So when the rotor turns around the stator, the magnetic field is changing. So when the conductor inside of that magnetic field, like the magnetic field gets stronger and stronger and stronger and strongest, and then it starts to go back to weaker, 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 it's called collapsing the magnetic field. And that's what's causing these electrons to be pushed, and then they're like pulled. So the stator system, this Magneto system, what it's doing is creating what's called alternating current, which means the electrons are going back and forth in the wires. This, as you saw in the video, what this does is it can take the alternating current. You know, alternating current is the sine wave, like in math. Remember in math, you see that sine wave? So what this does then is instead of having the electrons go back and forth, like up and down, positive, negative, what it does is it takes them with a diode, using diodes, and instead of like losing the electron flow on the bottom of the zero, what it'll do is it'll look like this. So what it'll do is flips it over and keeps pushing the electrons. That's what the diodes are doing inside of this. So again, that's why they call the rectifier. It's rectifying the AC current to DC current. Again, DC current is direct current. That means that the electrons are only flowing in one direction. So again, different types of different stators. This is out of a Briggs & Stratton Vanguard engine. So they'll look similar. This is out of a Polaris 500 carbureted four-wheeler engine. And this is actually from, I even labeled it, this is actually from a 1990 Suzuki 440 fan-cooled engine. Okay? So this actually fits inside, and you'll see this the way that sticks. And you got to be careful of this too, it'll pinch you. So again, this part of it is bolted to the crankcase, and the rotor is spinning. And there's the magic. It's like when you grab that pull cord on your snow machine, you give it a pull, what's the magic? Here's the magic. And you've got a conductor that is inside a magnetic field, or close enough to these magnetic fields, and it's just the way it is it's forcing the electrons. If there's connection, if the circuit is completed, the electrons will flow back and forth. AC current coming out of the Magneto, and then this can take that and turn it to DC current, so you can charge your battery and have your hand warmers and that kind of thing. So